Oh, yeah.
Anyway, but they were talking about taking the cells and growing them just like, you know.
Yeah, they've accomplished that.
Yeah, where they're just growing meat from a couple cells and there's your hamburger.
Jurassic Park?
Huh?
Kind of, yeah.
Jurassic Park.
Yeah, I mean, it's kind of nuts because I just think I don't want to eat something. I don't want to think that I had eyes and stuff. I mean, I'm good with that. Just pretending it just, you know.
Now, although it might not taste the best, it is the most efficient way to make a meal on Mars.
There's the catch.
There
Right.
is possibilities there, because then you can clone those cells
Right,
repetitively.
Yes. Yep.
And you've got,
Yeah, you wouldn't need
Endless.
chickens up there. You just
Right.
bring a little embryo up there with you and,
Yep.
you can cut butchering out of everything.
All right, so fertilizer and methane. The Martian crust, besides silicon and oxygen, it's made up of iron and magnesium, aluminum, calcium, potassium, etc. Nitrogen, phosphorus, sulfur, calcium, magnesium are some of the most basic minerals needed to produce crops. Nitrogen and phosphorus come from the manure, but it would be a struggle at first. With feces of ourselves and the small amount of livestock, even though they can transfer diseases, it's all we would have to help plants grow. Taking the methane out of manure to keep as a fuel source so that we have other ways to heat everything in the domes. So waste management. As much as possible, we can put certain products or materials into biodegradable containers so that they help enrich soil when the astronauts first start farming. Other than reusable containers like plastic, glass, or metal, we would use those for long-term storage. So by using biodegradable materials to store stuff, if it goes bad, then we can just put it in the ground to help enrich the soil.
Genius.
To save on water, we would have to filter the urine back into drinkable water. And small amounts of livestock can transfer diseases. This is the same thing. Sorry.
It's okay.
Okay, we're gonna watch this. You're gonna click on the links.
First one?
Yeah.
So one of the ways they get water on the International Space Station and on space missions is purification of urine. So that's real.
Alright, so food video first.
Everyone says we're going to Mars in 10 years, but what are we going to eat on the way? Anthony here for D-News, and over 100,000 people applied to be a part of the Mars One mission. That means one way or another, those people applied to die in space. Godspeed, you pioneers. I would go with you if I could bring my dog. We know that the Mars mission is going to be rough living, harsh conditions, danger at every turn. But what about the food? Space food is historically not great. It started out as tubes of protein puree and has ended up as some lovely freeze-dried, irradiated snacks and meals. Space food is tricky because scientists have to worry about nutritional content, ability to be reconstituted, how long it will last, how much space it'll take up, whether it'll break apart. Trace did a whole video about it. Check it out. It's kind of awesome. But here's the deal. Space food is made for the short term. Missions that last a couple weeks bring all their own food up, and the space station gets supply drops. A mission like Mars One spends a year getting to the planet and then another year or two getting reliable terraforming and food production going. So what are they going to eat? NASA has been wondering the same thing. So they commissioned the University of Hawaii and Cornell University to get their top chef on and figure out some healthy, long-lasting, and hopefully delicious meals. After a rigorous application process, 6 people were chosen for the High Seas mission to live in isolation on a faux Mars colony on a Hawaiian lava field for 4 months and just to figure out what's going to go on the Martian menu. The High Seas site even asked for community recipe submissions and got ideas like spicy veggie rolls made with reconstituted spinach and quinoa, and Cajun jambalaya made from rehydrated onions and celery. And a lot of spam. Spam was real big on the mission, because spam lasts through anything. Also, they were in Hawaii. So what's the best food they found? Soups seem to go over well, with the team really digging on mushroom and wild rice stew, borscht, and seafood chowder, which makes sense because they're easy to store and they're easy to make. It also mixes the fresh and freeze-dried ingredients together, which masks how weird, rubbery, and tasteless reconstituted chicken must be. Which leads to the most important recommendation the team made. If you're gonna go to Mars, be sure you pack a lot of sriracha. Like, a lot. Because the team says an essential part of any Mars mission is going to be spices and hot sauce. When you're eating a lot of rehydrated stuff, you're going to need it for flavor. Even more so in space, where your bodily fluids flow differently and clog your sinuses and puff up your face, which makes your sense of taste less sensitive. You can find all the recipes on the High Seas site, along with crew blogs and details about the other research they did. Cool stuff, like simulating daylight and using robots as companions. You know, the more I read about it, the more I'm happy to give up my potential spot on that first mission. I'll go to Mars when they get the first ramen place. You know, we should pick a couple of these and try them out. Let us know what we should make down below, and subscribe for more D News.
Let's do the second video then.
Plants evolved here on Earth, but what if we could take them with us to the stars? Hey gang, Trace here for D News with your weekly space update. Last year, NASA announced that we had found water on Mars. And that got some people thinking, could future astronauts grow crops in the Martian soil? It's taken us thousands of years to hone farming here on Earth. We could, plant crops till the cows come home, but what's good for the Earth's goose may not be good for the Martian gander, if you know what I mean. Soil needs a lot more than water to grow a plant. Soil on Earth contains living and dead organisms, including bacteria and plant matter, rocks and minerals, and nutrients like nitrogen. It takes more than 500 years to form an inch of topsoil on Earth. And as far as we know, Mars doesn't have organisms living in its soil to aerate it and break down the matter. So this is a huge challenge. Not all dirt is created equal. There are actually 70,000 different kinds of soil in the United States alone. So, to simulate Martian soil, we had to gather information about Mars first. The Mars Science Laboratory Curiosity has been doing just that when it wasn't joyriding around Mars and snapping selfies, of course. Martian soil contains carbon dioxide, oxygen, and sulfur compounds, as well as carbonates, or things that indicate the presence of water. It's about 2% water. NASA gathered soil samples on Mars and then composed an approximation of Martian soil using volcanic soil from Hawaii. From there, plant ecologist Uyghur Wamalink planted 14 plants and grew them over 50 days. Obviously, the plants were given carbon dioxide, oxygen, and water, but that's just the obvious resources. The seeds of a plant can sustain growth for a while, that's what they're for, to help the plant gain a foothold. But according to PhysOrg, they expected the plants to germinate and then die due to a lack of nutrients. The researchers were surprised to find that the plants actually did pretty well, using the phosphorus and iron oxides in the soil to take root. Unfortunately, the fact that the plants grew in a difficult soil environment is only one small part of the puzzle. The lower gravity and temperature of Mars will make it difficult for water to be pulled into the soil and tougher for the plants to evaporate their excess moisture. Plus, the sun is a lot farther away, so any Martian plants are going to need extra light. They're thinking LEDs at the moment, but no one is really quite sure. The moon is much closer, only a few days away. So to Newt Gingrich's delight, the moon will probably be the location of Earth's first extraterrestrial colony. Wamalink is also trying to grow crops in the moon soil called regolith, because our moon has no atmosphere. The regolith contains mainly meteorite-home rock dust, micrometeor debris, rocks, and volcanic blast. Not to mention radiation from the unchecked solar wind. Yay. It would be huge if we could manage to get crops to take root in any capacity on another planet. Not only because of food, but oxygen recycling purposes, and to give colonists something to do all day. It can get pretty boring to sit around in a spacecraft all the time, but that's another story. And if this doesn't give you the train conductor kick in the head excitement about the future, how about Shots of Awe with Jason Silva? Watch Jason explore technology, space, human nature, and love.
I think we're good.
All right, thank you for that. Next slide, please. All right, ice caps. There are 2 ice caps on Mars, one at the North Pole and one at the South. To prevent dehydration, a person would need to drink about 2 liters of water or half a gallon a day, which is a lot. On the North and South poles of Mars lies a thick stack of frozen ice sheets made of dust and water. The temperature on these poles can get as low as negative 243 degrees Fahrenheit, making it highly uninhabitable with today's technology. It gets so cold that carbon dioxide condenses directly into snow or frost until it's springtime that the CO2 becomes a gas again. And the temps get to about negative 202 degrees. So instead of becoming straight water, it sublimates and becomes a gas right away. Layers. So there are supposedly 4 different layers to Mars ice. The seasonal ice cap is the very top unit. It is composed of carbon dioxide or dry ice. It forms in each Martian fall and winter. Although it's most accessible, it's not the best for drinking water, seeing that it turns directly into gas by sublimation. The second layer is the residual ice cap. It's made of water ice, which is the best to collect for drinking water. The third is the polar layer deposit made up of most polar caps. It's the largest volume.
It's fun doing somebody else's stuff. Huh?
Yeah. This layer it's primarily ice mixed with dust, so it needs more filtration than the top layers. And lastly, there is the basal unit in the north and the Dorsa Argentina formation in the south. These are mixed with dust and sand glued together.
There's a lot of water on Mars. A lot of
Yes.
water.
Okay. Transport. So, melting the ice and transporting it would take a long time. First, there needs to be some way to heat it. Solar panels are probably going to be the best choice since it needs the sun. After melting the ice, it needs to be transported. And we would probably use a melt it in a container to send it back to the base through a pipe underground. I don't know what that is.
Auto video.
Yeah, you have to scroll down. It's within the article somewhere.
Found that one.
Water is the essential ingredient to life as we know it. Everywhere we look, water is where life is.
So that's why the mantra for Mars exploration has been, thus far, follow the water.
We know some of the places where water happens to be because that's critical. You don't want to send humans where there is no water.
On Mars, just below a layer of dry regolith, basically dry dirt, there's an ice table with ice.
You can drill for the water. Actually, you get to the ice, and you pull the ice. It's not any different than Antarctica.
There's so much water on Mars in the form of ice that if all of it were to melt at once, the entire planet would be 1,000 feet deep in water.
We already have the technology to just about perfectly recycle it if we need to.
They're going to take that water, clean it up, get all the sewage out of it, and treat it with chemicals and other things, and you'll be drinking it.
It's cleaner and safer than your tap water when it's done.
It's not just because we're going to melt it and brush our teeth with it, but also because water is made up of hydrogen and oxygen, and those are the two components of rocket fuel. And so you break apart the hydrogen and the oxygen, and now you've got this fuel source, and that can help sustain you and keep you in this place.
Oh boy,
Oh.
where's Ellie?
Is she
Is she
here?
planning on coming?
Oh, yeah, I assume so.
Yeah, usually she'll be showing up.
Should we take like a 5-minute break?
We could, or I could talk about how we would go about getting to Mars.
Yeah, we could probably talk about that.
Okay, we'll take a quick potty break.
Okay.
And then when Ellie gets here, I'll let her.
That was rough. That was rough.